I want to do it.
Yeah, so he's not here. All right, so what we're going to work on is drawing pictures of molecules. I'm going to give you a list of rules that are called rules for drawing dot diagrams of molecules. They're kind of like the dot diagrams that we drew for elements, but we're going to draw them for molecules instead. I'm going to start with something you're very familiar with, which is water. So if we wanted to draw a picture of a water molecule, H2O, I'm going to list the steps here. I'm going to draw the picture over here. So if we want to draw a picture of a water molecule, the first thing we need to do is add the valence electrons. So number one, add valence electrons. The valence electrons are the outer shell electrons. If you look at hydrogen, you will find how many electrons in the outer shell? Hydrogen. One. How many hydrogens are in water?
2.
So we'd have 1 plus 1. How many valence electrons does oxygen have? 6. So 1 plus 1 plus 6 would give us a total of 8 valence electrons in a water molecule. So far so good?
Yep.
Okay, step 2, draw a skeleton structure. Which is kind of appropriate because we're around Halloween.
Ha ha ha.
All right, the skeleton structure would look something like this. A skeleton structure. A question that should come up in your mind is, how do we know what to put in the middle? Does the H go in the middle or does the O go into the middle? And the answer to that question can vary. But generally, the element with the most open spaces in its valence shell goes in the middle. So if you look at oxygen, oxygen has a valence shell with 6 open spots. Oh, excuse me, not 6, I said that wrong. 2 open spots because it has 6 valence electrons. Hydrogen has a valence shell with only 1 open spot because hydrogen's outer shell is the first energy level, and the first energy level only holds 1 electron. Does that seem logical?
Yep.
Okay. So 2 open, 1 open on the hydrogen. That means oxygen goes into the middle. Another thing that determines what goes in the middle in some other cases would be the least electronegative goes in the middle, or you could say it's the element that's closest to the middle of the periodic table goes in the middle. All right. So in this case, oxygen would qualify by being closest to the middle of the periodic table, but it wouldn't qualify by being least electronegative, so you've got to use some judgment too. All right. Third thing you do is subtract 2 electrons per bond. Each one of these lines that we've been working with today represents 2 electrons. So 2 electrons per bond. How many bonds do you see in this picture? 2. So how many electrons would we subtract? 2 electrons per bond.
4.
That'd be 4. So minus 4, that would give us 4 electrons left over. So what I'm saying is, of the 8 valence electrons, 4 of them are already in the picture, and I have 4 more to distribute. Okay, so the fourth step is distribute the remaining electrons per the octet rule. What do you think octet means? Octet. 8. So you'd have 8 around everything. And what would be an exception to the octet rule would be hydrogen. So hydrogen doesn't get 8. Why not? Because its first energy level only holds
1, 2.
2. So for hydrogen, it's full with 2. But everything else that we'll work with, at least almost everything else we work with, will be full with 8. So things will want to have 8 around them. All right? So how many are around this hydrogen right now? 2. How many are around this hydrogen right now?
2.
How many are around the oxygen?
4.
4. Okay? So how many more need to go in around the oxygen? Oxygen wants 8. Right now it's got 4.
4 more.
4 more. So I can put 2 here, 2 here, Okay, and then I have 1, 2, 3, 4, 5, 6, 7, 8 around the oxygen. So this 4 electrons here that we subtracted are the 4 dots that we have right here.
So it's just kind of like the Lewis dot structure.
Exactly. These are called Lewis dot diagrams for molecules. All right. So one other thought, and we're going to shut the video down. Sometimes it doesn't work out perfectly. Here it worked out perfectly because the hydrogen needs 2, the oxygen needs 8. So it's fine, everybody's happy. But if you have too few electrons, what you're going to need to do is add, you're going to have to share more. So you add multiple bonds. By multiple bonds, I mean double bonds or triple bonds. And if you have too many, then you'll put the extras around the center. I'm running out of boards here, so I'm not going to write that down, but you need to put in your notes to put extras around the center atom if there's too many. We're not going to do any too manys for a day or two. Okay, you can shut the video
Shut
down.
the video off.